Humanity's blindness to cosmic peril. Hidden asteroids near Venus have the potential to impact Earth every 12,000 years. In a world filled with wonders and dangers, the reality of asteroids poses a unique dilemma. While they ignite excitement in the field of space exploration, these celestial bodies also carry with them the potential for catastrophic destruction. Recent research has shed light on a previously unrecognized hazard: asteroids lurking near Venus that could endanger Earth. These enigmatic objects, known as co-orbital asteroids, have remained undetected due to their close proximity to the Sun, raising alarms among scientists about our current capabilities to monitor them effectively. The enigma of co-orbital asteroids. Asteroids are not just simple rocks, they are complex entities that require vigilant scrutiny. Despite significant advancements in our space surveillance technology, ranging from teleportation systems to sophisticated satellites, certain asteroids continue to slip under our radar. Co-orbital asteroids in particular present a formidable challenge. Their orbits in resonance with Venus and proximity to the Sun render them invisible to many instruments we rely on for our safety. Even with cutting-edge telescopes and other spaceborne devices, tracking these offenders remains a daunting task. This situation prompts critical questions regarding our comprehensive understanding of cosmic dynamics and the behaviors of these elusive objects. Co-orbital asteroids orbit alongside Venus, and if they venture closer to Earth's path, the consequences can be severe, turning a peaceful night sky into a potential danger zone. Periodic collision risks every 12,000 years. A thought-provoking study conducted by researchers at the State University of Sao Paulo, led by Professor Valerio Caruba, opens the door to understanding this ghost population of asteroids. The findings indicate that, although many of these asteroids may dodge Earth without issue, gravitational shifts could occasionally alter their trajectory, placing them on a collision course with our planet approximately every 12,000 years. Utilizing supercomputer simulations, this research modeled multiple scenarios, some of which predict the grim possibility of an asteroid directly intersecting Earth's orbit. While such instances are rare and often seem distant, the reality is chilling. A solitary collision could unleash catastrophic consequences. The results of Caruba's study highlight the urgent need to track the trajectories of these space rocks and strategize for scenarios that could profoundly disrupt life on our planet. Implications of sudden and catastrophic impacts. Among the most alarming attributes of these hidden asteroids is their capacity to approach Earth unnoticed. In reality, scientists have estimated that we might have mere days to detect one before it strikes. According to Caruba's analysis, certain asteroids could reach diameters of up to 1,000 feet, generating impact events with craters spanning nearly 2.5 miles wide and releasing energy equivalent to hundreds of megatons of TNT. Imagine the repercussions if such a cosmic object were to collide with an urban area. The devastation would be immense, yet the truth remains: there would be little to no advanced warning. These silent cosmic entities could remain lurking in the shadows until the moment they become a threat. The thought of sudden asteroid appearances, leaving humanity unprepared to intervene, turns what once felt like the stuff of science fiction into a plausible scenario that we must now confront in earnest. Hence, enhancing our detection tools and strategies for tracking co-orbital asteroids is no longer a luxury, but an urgent necessity. Re-evaluating planetary defense strategies. Given the hidden nature of this cosmic menace, there's a growing consensus among scientists for a shift in our planetary defense strategies. Current monitoring primarily emphasizes threats that are easily visible, but it is crucial that we shift our focus to anticipate those that remain hidden. Solutions may involve launching probes positioned closer to the Sun to scrutinize conditions around Venus more attentively. Additionally, the deployment of space telescopes in inner orbits might significantly broaden our observational capabilities. This evolving threat landscape calls for a critical reassessment of our planetary defense priorities. International cooperative efforts, enhanced funding, and a heightened awareness of these invisible risks are essential moving forward. Safeguarding life on Earth hinges on our readiness to confront these unimagined dangers. By elevating our detection capacities, we can better fortify our planet against unexpected calamities, a persistent threat for future generations. Although these potential asteroid collisions may not be imminent, the message is clear. We must remain vigilant. It is far better to contemplate proactive measures today than to find ourselves in a reactive posture tomorrow. These celestial risks could one day loom overhead, not just for us, but for countless generations yet to come. Planetary defense doesn't belong solely in the realm of blockbuster movies. It's grounded in data analysis, modeling, and a commitment to heightened vigilance. The lessons we overlook today could potentially become our greatest threats in the future. If we aspire to safeguard ourselves from a fate reminiscent of the dinosaurs, monitoring the hidden dangers behind Venus is essential. Are we truly prepared to face this invisible peril to secure the safety of future generations?